Okay, so good day to everyone. I kindly ask to today's guest to switch off the mics, please, because in this way would be okay. Thank you very much, guys. Then when you will start talking, you can reopen it so there's not a lot of noise. So, hello everyone. I hope that you are doing well today. Welcome and thanks to join us very much in today's webinar. The series of webinar we have started some weeks ago is going on with a great success, and I hope that also today we will be able to satisfy your curiosity. My name is Giorgia Rossi, and I am the International Sales Manager of Gexcel. It is more than 10 years that we are involved in the development and production of solutions for the 3D surveying and mapping global market. And I am excited to host today's webinar because it will sound like a sort of intercontinental round-table discussion. Our guests today are all over the world, and their presence, I think, that will enrich the experience that we are going to talk about later. So first of all, I am glad to introduce Professor Giorgio Vassena, Gexcel CEO and Professor of Geomatic at the Brescia University. And Giorgio today will provide an overview about the fast mapping for the BIM and all the possible issues that this, I think, a huge and warm topic can have. And then, thanks to our South African partner, Autobuild, we will experience how Heron Technology has revealed to be a keystone for the digital twin of a South African hospital. And Mr. Dave Beatty, former CEO of Autobuild, will provide an introduction about the site and about the customer's goals and needs, and how Heron was able to achieve the goals. And the narration then will be carried on by Mr. Conrad Den Hoyt, who is an Autobuild expert surveyor, and who will describe how to move from the 3D real-time acquisition to the final deliverables. Before starting, before we begin, just some information about how you can interact with us. First of all, I would apologize in advance in case you would have some kind of delay for the connection, because as you know, in this period, connection is pretty overload, okay, but I hope that everything will go smoothly. How to interact with us? Your mics are closed, so you cannot talk directly to us. Of course, you can interact with us because there's a little window, a little panel that is there's a sort of chat box in which you can put your question, and we would try to reply in real time to your question. But don't worry, because at the end of the presentation, we would have some time for a Q&A. The webinar will be recorded for your reference, and so you will receive it later, maximum tomorrow, by email. So don't worry if you are scared to lose something. Now, let me go quickly through today's agenda. We will have a webinar introduction, and then the success case presentation, where we will underline the needs and the goals. We will then enter inside the technology used, and also we will discuss about the workflow that has been followed both on site and also on the post-processing field. We will discuss also about the result that we got, and then we will leave some time for the Q&A. Now I am pleased to pass the floor to Giorgio, who will give you a general overview about the topics webinar introduction. So let me please share with Giorgio. Okay, I just give to Giorgio the right of the organizer, and so Okay, here we are.
Hello, hello.
Yes, now we can
Hello?
hear you pretty well. Okay, now it's good.
Sorry for that. So, hello to everyone. Thank you, Georgia, for the introduction, and sorry for this connection problem. What I'm just going to introduce you is a very fast introduction about the topic. Okay, so everyone, we know that everyone is speaking about surveying, and let's say what everyone is expecting. So I think surveyors always, and I'm a surveyor, and I say, well, I always looking for high accuracy, targetless mapping with 3D laser scanner, to everything almost in real time. You can work outdoor, indoor. So every visit are what's, and of course, an easy process and fast data processing. So this is what everything is expecting. And to be frankly, the technology is really rushing in this way. Okay, so we have seen in the last times, in the last period, that a lot of let's say a lot of technologies has come to life, like UAV, mobile mapping system, and let's say that all these technologies now are very focused on creating, like to say, from the point clouds, we say a BIM model. Okay, and about creating a BIM model, what we see that often we call BIM in reality a 3D CAD model. Okay, so it's so we are facing this problem now in the technology. We always speak about BIM technologies, but in reality, the biggest problem now is to go as fast as possible from the point clouds to the BIM model. And today we are going to see how we can face this problem and to give a solution, okay, fast solution. But as a technology of Gexcel, okay, we can say that all these developments we have seen in the technologies have lasted a big problem, let's say, because using, for example, UAV to make 3D models from airborne-based systems, you can easily have a model from, say, flying on a building. You can easily map in outdoor with mobile mapping systems. But the big problem that still exists now is when you go from outdoor in indoor. Indoor, you don't have a position, and so everything becomes more difficult. So when we work indoor, we have still the, let's say, traditional terrestrial laser scanning approach. That means, you know, static scans, time of scanning. Sometimes you are still forced to use targets because the automatic registration not always works in the perfect way. And so now we can say that this problem was the last big problem in 3D mapping, in creative 3D model, digital models. And what we see that we tried as a company to overpass this problem of fast indoor mapping, to overpass the terrestrial laser scanner low scanning approach, and to be able to provide a reasonable accuracy, okay, and to have a device that is not too heavy, okay. So for this reason, we can say that we found a solution to solve the problem. This problem of to have a fast system to map indoor environments, to have a reasonable accuracy. Not always we need millimeter accuracy, but in some application it's, and we are going to see today, for example, an application. We can add an example. We work well and to have to satisfy the customers and our needs with a centimeter level accuracy. And using a system that is light, portable, few tools that you can move in construction site, in buildings, with no problem. So the device that we are going to present today is, we think is a very interesting solution. Okay? But what is great, I think, is okay, with this system we are going to present, you can have very fast BIM model, let's say 3D CAD model of reasonable approach, reasonable accuracy, let's say solution, and that's I think is perfect for this application. But what is fine, I think, okay, and I'm not going into the details of this because our colleagues now later we will present you how you can create a satisfied BIM model from using our mobile Heron system. But it's what is incredible. It is, for example, you see here with the State Palace in Rome. As you see, it's possible to have a reasonable good accuracy model of a building using Heron. Okay, but what is incredible, I think, is that a lot of things can be done with this system. Okay, so I think it's a new market and services are coming to the market using the Heron mobile mapping system. For example, I mean, usually when we speak of level of accuracy of 3D mapping of a building, we for example, we ask millimeters, but if you think in reality, sometimes you really don't need this kind of accuracy in all the buildings. I may make you, for example, some example, okay? For example, if you look at this hospital, this is a very fast result obtained by a mobile mapping system by Heron, okay? You have all this geometry, all this map, and this map has a 2 centimeter accuracy. And for example, you can use this centimeter level accuracy to position doors, windows, pillars of the building. So when you want to create a BIM model in the actual buildings, often you just need to know where the pillars are, where the doors are, where the windows are. But the position of the window and of the pillars can be of 2 centimeter level with no problem. Okay, and the real geometry of the windows, of the door, of the pillar is measured directly by the surveyor. So for example, you can use this FAL mobile system to place in the right place the objects that you measure with higher accuracy with different systems. For example, look at this industrial place. We have several customers that, for example, they have to map industrial sites. Okay, and all these elements are the same for all the industrial plant. Okay, what they have to know? They have to know where this, let's say, symmetry or this geometry changes. For example, you have in some places you have the geometry changes. So you can use, for example, a fast mobile mapping system as Heron just to map all the sites and then know where you have classical pillars, where to position the different geometry. And this different geometry, of course, is mapped with a terrestrial laser scanner with high accuracy, and you model with TLS. Okay, but then with Heron, you can map larger regions and just to know where to place this geometry that you map with much accuracy with terrestrial laser scanner. Or, for example, look at this building. Of course, if you have a series of this building, this small part of the geometry of the windows are well measured directly, but with Heron, you can map all the building and to know in 3D where to place the model that you create with another approach. And as the last topic, I'd like to introduce you to a very fast example of how this system can be used to make what we call BIM check. I think something that we are always asked is, when you make a 3D surveying of an existing building for renovation activities, for example, you have a big old industrial site and you want to make a market inside there. So you have to map with laser scanner all the existing building. Someone makes the BIM model, so they make the scan to vector activity using terrestrial laser scanner, the classical approach, we can say. At the end, you have a 3D CAD, a BIM model of the existing site. You give this model to someone that has to make the project, the new project on this model. Now it's becoming more and more important to be able to check, to validate the BIM model that was created from the scan to BIM process, because if some errors are present, or from the time you make the surveying something has been changing, you can create a lot of business loss, of economies loss. Why? When because you can place a pillar, the project manager can place a pillar where something is existing there. So how to validate a model, a BIM model? With Heron, you can, for example, this is an example of a palace in Italy. You can load the BIM model in the Heron device. So when you load this model in Heron device, you can start working in the site. And for example, in this case, you see, I got the geometry of all the metallic structure of this building. Why I highlight this? Because the unique solution, the unique tool that have Heron, you can see here. Okay, you load the model of the existing site, and you start. You can start walking, like in this fast video. You see, you are walking, and immediately in real time, you see in the monitor in red the elements that are not present in the BIM model. Okay? So both in real time, but also in post-processing, you can highlight if any elements has been changed, has been moved, so you can validate the BIM model. So in this case, for example, 2 parts were lost. You don't know if they were okay. Probably the guys that made the scan to BIM process, they lost to make these elements. And so now you see here in real time in red during your mapping process. You see in real time in red that this part are not present, and so you can tell this to the software guys, and they can update the model with this correct part. Okay. And last but not least, and then you can of course make also a let's say as built as design comparison. The only problem, of course, that with our system, this level of check, let's say geometry check, is a level of centimeters. So often is not, you have not enough accuracy to do that. But as last, of course, what we have in mind, and a lot of our customers use in real time, is that not in all your surveying you need the same accuracy. So what is great that with Heron, you can make a multi-resolution, multi-sensor model. So you can map a large site with Heron with the centimeter accuracy, 2-3 centimeter accuracy of Heron, and then to insert in this model the parts of your buildings that you need in higher resolution with terrestrial laser scanner. So for example, this is our location in Italy. This is the mapping of using Heron, and you see here is the 3D model acquired with Heron with 2-3 centimeter resolution, and then in this part we need a much higher resolution and accuracy, and in this part you see we can easily map a TLS high resolution point clouds that fully integrate the general the general surveying. So this is also important, because in this way you can have the accuracy and the resolution, the higher resolution and high accuracy of terrestrial laser scanner only when you need it, and you connect parts of your site with low resolution and fast and let's say cost-effective approach of Heron. So I think it's over now. I leave to our colleagues to keep going in our presentation. Thanks for listening.
Thanks a lot, Giorgio. I think that you have clearly pointed out a warm and delicate topic with all the possible issues that affect the technicians, so people who work on the field and who have to move from point clouds to BIM models in the easiest and fastest way. And I really think that today's experience will help to learn more about how this would be possible by Heron portable mobile mapping system. And I would like now to enter in the success story together with Dave. So let me take, sorry, Giorgio, can you give me back the control of the presentation, please? Okay, here we are. So let me quickly go to our starting part, and here I kindly ask to Dave if he could provide us an overview about the site.
Thanks, Georgia, and thanks, Giorgio, for all the information there. I'll just give a very brief description of where this job was. It's ODI, which is OD Community Hospital. It's situated at a place called Mabopani, which is near to Tshwane. Tshwane is used to be called Pretoria, and the whole area is not far from Johannesburg in Gauteng province, South Africa. Mabopani is a generally poor rural community where the population consists almost entirely of previously disadvantaged people. OD Hospital has been in existence for 28 years. Just a little bit about the hospital. It's got about 230 beds, and it offers services such as outpatient department, wellness, eye and dental clinics, rehabilitation unit, occupational health and safety unit, reproductive health, and the hospital also has 24-hour service of theatre, medical and surgical wards, as well as pediatric, maternity and neonatal units. OD District Hospital is also a referral centre to about 19 clinics around Tshwane. The hospital consists of several buildings, some of which are 2 or 3 floors, and they're connected by walkways. Yeah, that's the description. Thanks, Georgia.
Okay, Dave, thank you very much for this site overview. Of course, I think that there are some recurring building standards that we can find almost in all the hospitals around the world. But in my opinion, each site has its own challenge, and I think that each site has to be considered as a unique case with its own peculiarities. And so, Dave, which were the customer's goal to be achieved? Sorry.
Okay. Autobuild Africa is actually a supplier of surveying equipment, and as such does not normally do surveying work. In this case, however, an architectural practice approached Autobuild to do a full scan of the hospital as a proof of concept exercise. The ultimate customer was the government, who would use the result to plan future expansion and planning. So what was the brief? The client required 2D blueprints and 3D point clouds of the hospital, and they required it in 1 week. Our client then used these to create BIM models using AutoCAD and REVIT. This whole thing happened last year before the COVID-19 outbreak. The work was to be carried out without interfering, blocking, or delaying the daily hospital activities. This was a working hospital and there was activity 24/7. Challenges were aplenty. Spaces sometimes very cramped. There were sensitive areas where hospital scrubs, PPE, were required, and some areas where minimal time for scanning was allowed. This could obviously not be accomplished with conventional tripod-mounted scanners, and the obvious choice was the entry-level handheld Gexcel scanner, the Heron Lite. And yeah, that's about it. Over to you.
Okay. Thank you very much, Dave, to have point out the goals and the needs. So let me quickly now give an overview about the system used to achieve the goals that you have just mentioned. And here we go. This is Heron, the portable mobile mapping system used. Heron is a portable backpack solution, SLAM-based, enables to move anywhere. With only 2 kilos weight, Heron Lite is adaptable for any staff to use in any kind of environment. Heron is warmly appreciated because it lets the surveyor move around freely and easily without need to stop somewhere. And of course, this sensibly influences the operative cost because you do not have to hire a big survey team or to do multiple survey, because in a single survey that can be carried on only by a person, an operator, will produce a complete accurate survey. No time-consuming calibration and initialization procedures to carry on. Heron acquires data in continuous with a maximum range of 100 meters, achieving centimeter accuracy. The versatility and the speed of Heron as well as the ability to acquire huge and complex area has seen the technology being used very much in sensible indoor environment like the hospital that we are going to experience today. And so let's now move on to discover how concretely the job has been carried on. And I would like to invite Conrad to talk about the project workflow. Okay, Conrad, can you hear us?
Hello, yes, I can.
Okay, super, thank you.
Okay, thank you, Georgia. Hi, everyone, thanks for joining us. I'm going to talk, just give a little brief outline on how our scanning went. So the complete hospital scan took about 4 hours to complete. Firstly, myself and my colleague, James, went to the hospital the day prior to suss out our plan, workflow, and to make sure that everything would be accessible. We then realized that scanning the inside of the building would not be viable to do during the day, as some of the departments, there were hundreds of people seeking medical attention. So we opted to scan the outside of the building and some of the departments where there was minimal foot traffic, such as the dentist, laundry, and x-ray departments. We then went back to the hospital later that evening after visiting hours. This allowed us to scan the hospital without interfering with the patients and staff. There are about 5 buildings that are all connected via one long passage. Some of these buildings are also multi-story. I scanned the passage first, making this my anchor point for the whole scan. Every scan after that, we started in the passage, scanned the various departments, and ended the loop back in the passage. James and an assistant from the hospital would walk around ahead of me, making sure that all the doors were open, as SLAM technology requires that doors be open prior to the scanner operator arriving, entering, and leaving the area, as well as, of course, informing the staff that we are approaching. Certain areas such as the neonatal and surgical wards were more of a challenge due to the health risks and that were entailed towards the patients. So the correct PPE and sanitation had to be applied prior to entering those departments. This was a very effective method and we did not have to rescan any sections. The Heron was perfect for this as it allowed us to obtain a high quality scan with minimal interference to the staff or patients. Okay, so yeah, that was the scanning. We can move on to the processing part.
Okay. Thank you very much. Just I'd like just to show one of the result that you got, and then of course I will leave you the floor to talk more on this. So let me just quickly open this blueprint that was one of the deliverable that you have created after the scanning process. And this blueprint or X-ray orthophoto can be automatically can be created by from Heron data, and of course the blueprint can be created oriented as your reference. It can be a plan view, a section view, a tilt view. In this case we will see that you have mostly work on a plan view in order to extract the plan of the hospital. And the blueprint can be navigate and it can, in my opinion, be used as a very useful and quick product to deliver the job in 2D, but also to let the people navigate and investigate the model, especially people that are not so familiar with the 3D, and so they are much more confident to work on 2D view. And this is mainly the goal of the blueprint. So for example, in this blueprint that can be accessed by a free viewer like the one that I am using now, you can access to your data both on a computer, and as I am doing right now, or you can also investigate your blueprint just using, for example, a Microsoft tablet on site. And the tool allows, for example, to take very easily some measurement, like, for example, linear distances. Of course, there are some settings, so you can change the dimension style and so on. This is also pretty useful because you can easily get also the information about, for example, the area of a part, and so you can continue to investigate on it in terms of also on dimension and navigation. I would now let go back to the presentation, and I will pass again the floor to Conrad after this first overview about the GOBLUEPRINT, so that he can explain you better about all the results that they got during the job.
Okay, thank you. Yeah, once the scan was done, we had to process everything back at the office using Heron Desktop and Reconstructor. The total processing took about 11 hours to complete. This was my first big process. I realized with experience and the correct hardware, the time taken does reduce dramatically. First, we took the Heron mobile mapping data and optimized it in Heron Desktop. Using its very robust patented algorithm, the software globally optimized the scan and gave us a fantastic result. In the global optimization, there are a number of ways to align your common scan clouds together. The scans that were done in more open areas had more common clouds automatically aligned with ease. The areas such as tight, overcrowded storage rooms took a bit more time, but eventually got to where they needed to be in terms of accuracy. This was a great learning experience. We moved over to Reconstructor in order to clean the data and extract the 2D blueprint and 3D point cloud, which came out quite nicely. The great feature that helped tremendously is that Heron Desktop can remove moving objects, such as people walking. This helped produce a nice, quick, clean cloud. The 2D blueprint and 3D point cloud was then sent to our customer as per their request for the final REVIT and CAD product to obtain accurate dimensions of the rooms and buildings. Okay, and you can go to the next one to see what the outcome was. Okay, thank you.
Yeah, this is the result of the REVIT project that has been created based on the blueprint that you provided and the point cloud. So all the data has been imported to REVIT, because from Reconstructor you can enter inside the Autodesk environment directly, because there is this direct integration, and then in REVIT all the modeling part can be carried on in this way.
Yeah, correct.
Okay, so I think that it has been pretty impressive in my opinion, especially because we have seen how fast you can get the complete BIM model from a point cloud. Before ending, I would like to thanks again our guests, Giorgio, Dave, and Conrad, for the availability to present a so interesting and work topic. Furthermore, thanks to all of you to have joined today's webinar. And now we would be pleased to reply to some of your questions. So, I mean, stay with us just for a while again. And Conrad will help us, of course, help me, sorry, to reply especially to the most technical question. And also if you have some curiosity or something that you would like to experience more about this this project. Also Giorgio is with us, and also Dave. So guys, I would kindly ask for your help in case I am not able to manage the, how to say, much more interest question. For example, one of our attendees is asking if the Heron can be used also in underground mine. Yes, of course. It can. It is used in underground mine. Underground mine is one of the main sector in which Heron is used. And next week we will have a dedicated webinar on underground mining. So if you have time and if you would like to experience an underground case with another of our partner from Russia, please join us. I have some okay, let me see, because there are a lot of questions, so I would try Giorgio, sorry, can you, there's a question that perhaps you could help us to reply, because people here are interested, because they have been pretty impressed about your, I mean, the topic of the real-time change detection, especially that this can be carried on using also a BIM model to check the as design, the BIM. And so one of the attendees is asking is if our BIM model is one, I mean, is georeference, okay? If the BIM model has got its own georeference coordinates, how to georeference point cloud taken by Heron onto this model, how it's possible?
Do you hear me?
Yeah, we can pretty well.
Okay, let's say when you so thank you for the answer, because for the question, because it's a very interesting topic. Well, in this feature runs mainly in the Heron AC2 device, because it needs a more elaboration power by the Heron. So it's another version of Heron. What's happening is very, let's say, impressive, because when you load the BIM model, when you have a BIM model, you have to make a pre-processing in your laptop, and then you transfer this file in this, let's say, reference file in Heron. When you go on site, what you have to do? In reality, you have not to make a mapping and then to move the point clouds in the reference station, in the BIM model reference system. In reality, what happens is you move the model in Heron. Then when you go on site, you have just to tell to the system very roughly where you are. So you visualize the BIM model in your monitor of your control unit, and then you say, please, Heron, automatically georeference yourself. So you have just to say in which room you are or wherever you are. So when you say, well, I'm almost here, and the system automatically move Heron, understand where Heron is in your site. So from that time, the system automatically fit the 3D surveying to the reality. So you don't need to just to make any georeferencing problem, because the system automatically do it for yourself, for you. Of course, this is for the real-time approach. Otherwise, if you want to make in post-processing, you have to move in your site, and then when you have your 3D point cloud model, you have to move to reconstruct the post-processing software, and there you can make every georeferencing approach. But for real time is great, because you have just to go on site, load the model, and tell the system, please find your position automatically. I hope it's clear.
Okay, thank you very much, Giorgio. Then I have a question for Konrad. If you could reply to the attendee, Konrad, because they have understood that you have carried on the job indoor and outdoor, and they would like to know a little bit more, how did you manage it? I mean, if you start in one position because it's mandatory, for example, to start in one position, or you are free to start wherever you want, if it's mandatory to close the loop or something like that. So they would like to learn a little bit more on how you carried on the survey on site.
Sure, no problem. Well, for this scan, I started on the outside just to get a complete loop around the perimeter. Once I did that, I then did the scan on the inside, and as there are passageways that go through the building, they also lead to the outside. And I managed then to walk from the inside and the outside and just connect the inside and the outside loops together. You don't have to complete the loop, but it is very much suggested that you do. This just helps the IMU and your scan go onto a level playing field. And this then, with your common scan points, when you start processing everything, it will then link everything together, and the software makes it very easy to do.
Okay, thank you very much, Konrad, for the clarification. It is possible to export data to ArchiCAD. Yes, it is. There's not a direct exportation, like, for example, the one that we have for AutoCAD, in which we have the direct, how to say, a sort of connection, because, for example, the orthophoto can be imported directly in AutoCAD just using a script. But of course, it's possible to export for our ArchiCAD, because, with this answer, I'd like also to reply to another question. From Reconstructor, you can export in several open format. In terms, for example, of section, if you have to extract, for example, cross section, you can export in DXF, and so you can enter inside ArchiCAD, BricsCAD, AutoCAD without any kind of problem. On the other side, if you have to transfer your 3D data, like for example, point cloud or part of the point cloud or point cloud slices, you can export from Reconstructor in open format like E57, PTX, LAS, XYZ. So you can use this these interchange format to enter inside ArchiCAD or AutoCAD or BricsCAD or any other kind of CAD. And another thing, just to close this discussion about which kind of data you can transfer and also the format, in Reconstructor, that is the software that Conrad mentioned that he has used to process the data and also to extract the deliverables. You can manage also and you can create also mesh models. And so if your need is moving to ArchiCAD, AutoCAD, or to any other kind of software with a mesh, you can do that, because after creating the mesh in Reconstructor, you can export in really many open format, VRL, STL, OBJ, PLY. And so what we try to guarantee is a sort of continuity and integration of the deliverables in the most used and common software to, finalize and to end and close the data process. I have a question for Dave. Because there's someone who is asking for if you would like to have a demo in South Africa, would be possible to arrange? Do you have the system? Or so Dave, if you can reply, generally speaking, of course.
Yes, I'm no longer located in South Africa, but Conrad can certainly answer that. He does have a system there, and he can do demonstrations, obviously depending on the lockdown situation, but yes, we can do demos.
Okay, thank you, Dave, for the availability. So we will keep in touch after this this kind of issue. And okay, I think that we have reached our time for today. Once again, thank you very much for joining us, and really thank you very much to Giorgio, Dave, and Conrad to sharing their experience. I'd like to, underline again the next event, for example, next week, because we have a huge interest in this underground mining topic. So next week you can join us. And if you want also to know which are the next event that we are going to organize, please follow us on our social network so you can be updated about the next event. So once again, thank you very much for your time and joining us, and I wish to all of you a nice time.
Just to mention that all the questions will be answered by email. Yeah.
Yes, of course. Thank you very much, Dave, to have underlined. Yeah, thank you.